Hello everyone. So today we are going to begin our discussion on the link layer. So far we have discussed the application layer, the transport layer and the network layer, and today we are going to discuss the link layer. So first, what are the goals of this chapter? We're going to understand the principles behind the different link layer services. Then we are going to talk about error detection and correction. We're also going to look at as how multiple routers and hosts in the network share a broadcast channel that is known as multiple access. And then we were going to look into link layer addressing. Link layer addressing is a little different, is slightly different from the network layer addressing or the IP packets, and we'll look into that. So first, in this introduction, we'll just cover what are the different services given by the link layer and talk about error detection and correction. But first, let's look at some terminology. For the purpose of the link layer, we would consider that all hosts and routers in the network are known as nodes. Now, the communication channel between two hosts or between a host and a router, basically between two nodes in the network, is called a link. Now, the link can either be wired or can be wireless. So this link here between the two routers is actually a wired link. Similarly, the link between this mobile phone and the cell phone tower here is a wireless link. The laptop is also communicating with this access point using a wireless link. So links can be both wired and wireless. Now, the layer 2 packet, the terminology for that is called a frame. And what it does is it encapsulates a layer 3 packet or an IP packet or a datagram, to be more precise. So if I want to give you a one-line definition of what the link layer does, the link layer's responsibility is to transfer datagram from one node to the physically adjacent node over the link. So for example, here these two routers are connected by a wired link, and the responsibility of the data link layer is to transfer data from this node out here to this node here. So that is the function of the link layer. Now, there are different kinds of protocols that operate over the link layer, and there are many versions of it. The two most famous ones are Ethernet, which is used in a wired network, where you have, and that's basically this technology that's used when you connect an Ethernet your computer via an Ethernet cable. Or the other one is the Wi-Fi network, or it's also known as 802.11. So it's a wireless link layer protocol. Now, there are multiple link layer protocols and they might provide different kinds of services. And we will look into the kinds of services provided by the link layer next. But before we move on, I'll going to give you a transportation analogy so that you have a better understanding of the link layer. So say you are planning this trip to go from Princeton to Lausanne. Now, we've looked at the one way to go about is you could take a limousine to go from Princeton to JFK. From JFK, you could take a plane to go to Geneva, and then you could take a train to go from Geneva to Lausanne. Now, these are the three links of your trip. So the first link is to reach JFK from Princeton, and then you have to fly from from JFK to Geneva, and then from Geneva you're going to Lausanne. Now, the tourist is you, and we could think about the tourist as a datagram. Now, each of these legs is actually a communication link, and the transportation mode can be thought about as a link layer protocol. So the limousine is one kind of link layer protocol, is the plane is another kind of link layer protocol, and the train is another kind of link layer protocol. But they can provide different kinds of services, but overall the goal is to get you from point A to point B. So the goal of the link layer protocol is to transfer data between the two nodes communicated by a link. So I hope this transportation analogy gives you a better understanding of the link layer. Now, what are the different kinds of services that the link layer provides? This is an abstract level of the services that it provides. One, it provides framing, that it takes the datagram from the network layer and encapsulates it in a frame, and it does so by adding some headers and trailers. The next is it uses MAC addresses to do the addressing, and that it puts in the headers as well. Just remember that the MAC address is different from the IP address, and it provides and it's used for a different purpose. So I just want to bring this point now, and we will get into MAC addresses in greater detail later. The other thing is you want a good link layer. By good I mean it in quotes. You want it to be able to transfer data reliably between adjacent nodes. Now we looked at a reliable data transfer protocol in context of the transport layer, where we looked at TCP. But we don't need something as complex as TCP for the link layer. It is much more easier to provide reliable data transfer in the link layer, especially if you are using a wired link. However, if you're using a wireless link, the data rates, the errors can be much higher. So that is one more service that the link layer provides. And how this reliable data transfer takes place, and how framing and link access also takes place, we'll look at this in a little more detail later. But for now, I'm just giving you a high-level abstract view about the services provided by the link layer. The link layer, I would like to mention, also gives flow control. It does error detection and error correction in some cases, and it's both half duplex and full duplex. So these are the different services provided by the link layer. We will begin by talking about error detection and correction in this lecture. So before we talk about error detection and correction, which is going to be at the later part of this lecture, I want to quickly talk about where the link layer is implemented. So far we have talked about the application layer, the transport layer, and the network layer. All the application, transport, and network layer are all implemented in software. The link layer is implemented partly in software and partly in hardware. So this is the first connection. The link layer is the first connection between hardware and software, and it's implemented in the NIC, or the network interface card. So this figure here would give you this figure here will give you a better understanding of where the link layer is implemented. Now, the other thing is, I want to give you a brief overview of how two adapters or two hosts connected by a link communicate. So I'm sorry. So what happens is the datagram, which comes from the network layer, is encapsulated in a frame at the sending side. And at the sending side, what the host does, it adds error checking and some flow control bits. That is what is called a frame. It then put on the link. The link carries it, and the receiver then receives this frame. When the receiver receives the frame, it looks for errors, and if there are no errors in the message, it extracts the datagram, and then it passes it on to the network layer. Okay, so this is how the link layer actually works. So we'll end this lecture, as I was mentioning, with some brief discussion about error detection and correction. Now, how does error detection work? So let's consider this simple diagram here. So first, this portion here is the sending side, and this is the receiving side. Now what the sender does is it takes the datagram from the network layer, and let's assume that the datagram is D bits. It adds something called EDC, which is the error detection and correction bits. Those are added for redundancy. So if you don't have additional bits, there's no way for you to detect error. Now, what I want to say even before I get into error detection and correction is error detection is not 100% reliable, and we'll look at an example of this. So first, the datagram consists of these D bits, and there is this error detection and correction bits. And what is done is, once these error detection and correction bits are added to the D bits, the sender puts this packet onto the link, on the physical link. And the physical link is prone to error, and you could think of the physical link as this wireless link, which can introduce a lot of errors. So what happens is, when the receiver receives the frame, both the capital D bits could be modified, or this error detection and correction bits could be modified. That's why we have D prime and E prime here. But we are not bothered about the error detection and correction bits that much. What we want, or what the receiver wants in this case, is to check if D prime is okay. And when I say that D prime is okay, what it means is D prime the same as D? If D prime is same as D, what it will do is it will transfer this datagram to the network layer. Otherwise, it would say that an error has been detected. So this is the basic principle through which error detection occurs. Now let's look at a concrete example of error detection. So here we'll look at single bit parity. In a single bit parity case, what happens is each bit, as you know, can either take 0 or 1, and with this D bits, a parity bit is added. So what happens here is as you can see, there are odd number of ones here. There are odd number of ones here. There are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 ones here. And the parity bit has been set to 0. So the parity bit has been set to 0, which says that the number of bits, number of ones in the data bits is odd. So say when the receiver receives the data bits and the number of the second 0 here, this one here, is flipped to 1. What would happen is the number of data bits will have an even number of ones, but the parity bit is 0. When a parity bit is 0, it means that the number of ones that are there should be odd. But as you can see that if this single 0 is now flipped due to an error in the channel, then the number of bits in the D bits is going to be even. In that way, the receiver can detect that there is an error. But as I said, that error detection and correction are not 100%. Say the second 0 and the third 0 both got flipped with a 1, which is this 0 out here and this 0, both got flipped with a 1. Then the number of ones would now change from 9 to 11. So they are going to increase. But the number of ones is going to remain odd. With what this is going to result is that the parity bit is set to 0. What this would mean is that you would not be able to detect any errors here. What the receiver would say that it has received this bit correctly. So say with a single bit parity, you can only detect single bit errors. So it's only capable of detecting single bit errors. Further, with a single bit parity, you can only detect errors. There's no way for you to correct any kind of errors, and that should be obvious with this example. A simple way to correct errors is to use two-dimensional parity check. So here, what happens is you have parity along, so all the numbers are arranged in the form of a matrix here, and so say the 15 bits are arranged in the form of a matrix. So it's a 3 cross 5 matrix. So there are 3 rows and 5 columns. Now there is a parity bit for each of these bits here. So for each of these rows here, what happens is if there is an error, say, and what I mean by that is, say this bit here got flipped with a 0. What you can find out with a single bit parity is this one of these bits here have been flipped. So this entire row has not been received correctly. That is the detection part that you can do with single bit parity. Again, if you look along the column, what you can see that there is again using single bit parity, you can see that there is some error along this column. Now the intersection of the row of the column and this row is going to give you where the error precisely occurred. So using two-dimensional parity, you can not only detect single bit errors, what you can do is you can also correct single bit errors. Now in this case you've detected that the error is here. and as a bit can only take two values, 0 and 1, you know that the actual value that was transmitted is 1 and not 0. So using two-dimensional parity, you can correct for single bit errors as well. Okay. With that, we would end our discussion today, and in the next lecture, what we will do is we'll talk about multiple access protocols. Thank you.